Welcome back. At this point, we've covered a number of input functions, and schemas are an important part of all of them. By default, input functions try to infer schemas as you read data into polars. But you may run into instances where infer schema doesn't work as expected. In this video, we'll talk through important tips to help you build and use DataFrame schemas more effectively. Now, the schema class is essentially an ordered mapping of column names with the data types that should be used. Every time you read a file into a Polars DataFrame, a schema is automatically generated. You can call the schema method off of any DataFrame to display it. Let's show you how to do this. First, let's come into this first cell here and run this code. Now that we have our Polars library, we can read in our data variable. We'll say pl.read_csv. And in this case, we're going to use the employee's CSV file. Okay, now we're going to type schema, set it equal to data.schema. And this is essentially going to give us that schema that we've been talking about. Let's go ahead and display it here in our schema variable. When we run the code, we get the schema for our employee's DataFrame. By default, Polars has inferred the schema and returned the data types that enabled it to successfully read in the CSV file. But in practice, you may run into issues with Polars inferring your schema correctly. We have another CSV file called properties that will read into Polars. This data contains synthetic home properties with address, state, and zip code information. So we're going to come into this next cell. We're going to type data, redefine that variable there. Then we're going to say read CSV once more. This time, let's grab our properties data set. And let's go ahead and call the schema off of this one. When you scroll down and click on this expand element here, you'll notice that there was a parsing issue. In other words, the infer schema functionality failed. The reason we did not parse the data successfully was because Polars only scanned the first 100 rows of data and found a 5-digit zip code format. What Polars did not see is that there is a 9-digit version that contains a hyphen in later records. Polars does provide some possible solutions to resolve this issue. The first recommendation is to increase the length of schema inference. By default, Polars only scans the first 100 records, but you can change this to whatever you'd like. Let's do that now. So I'm going to come back up here and grab this same chunk of code, just paste it in below, and then we're going to use the infer schema length parameter and set this equal to 500. Now we're setting it equal to 500 because that's how many rows we have in our data set. Effectively, this is going to now scan the entire CSV file, that is all of the columns in the CSV file, in order to get the correct schema. Let's go ahead and run this. And in the output, we have a successful read. Keep in mind that while you can change the schema inference length to whatever you'd like, it does slow down processing speed. In practice, you might use read CSV or scan CSV initially to infer the schema and then save it. Once you have a valid schema, you can pass it into the schema parameter. This will greatly improve your data processing speed, especially for large data sets. Now, as I was recording this video, I noticed there was a small bug in the second recommendation. You'll notice that it uses dtypes as a parameter. The dtypes parameter was renamed to schema overrides in version 0.20.31. If you try using that with any newer version, you'll get an error because it does not exist. That said, if you know the data type that needs to be used, you can pass it into the schema overrides parameter. This option does not require that you know the entire schema. Let's demonstrate that now. So once again, let's go ahead and grab this same information, and we're going to remove the infer schema length parameter and instead swap it out for schema overrides. Now what we need to do here is pass in a dictionary. So we need to know the column, which is zip codes, or zip code, excuse me. And we got to make sure that it's exactly matching what we have in the file, so I need to uppercase the zip there. Okay, now we can go ahead and pass the value, which is going to be the data type that we want it to be read in as. So since we know that there are 9-digit zip codes with hyphens, we're going to pass in this data as a string, which is what it inferred previously. Okay, let's go ahead and run this cell. And when we run this code using a schema override, we get back the same schema as above. Now, schema objects are very simple, but they can be powerful tools for managing data pipelines. There are currently 3 methods that you can call off of a schema. Let's quickly walk through each one. So let's come down into this next cell here, and we're going to go ahead and type schema. And then the first method we're going to call is the name method. The names method. And that is basically going to give us the keys for each of the data types that we're using. So essentially the column names of the dictionary. Let's go ahead and run that. So in the output, we get all of the column names, and we can similarly get all of the data types that correspond to those. Let's come down to the next cell and type schema. And this time we're going to type dtypes. And once again, we get back a list, this time with the Polars data type that is associated with each of those columns. Okay, the final option is to get the length of the data set. So you can basically count all of the columns that are in the schema. So let's go ahead and type schema. Schema dot, and then it's len for the length. Run that, and we can see that there are 10 columns. In addition to being able to get information about a schema, we can alter it as well. In our case, we have the schema for our employees data set. When we read this data into our data frame, we did not ask Polars to parse the dates in the file. As a result, the date of birth is currently a string value. Let's alter the schema so that we can read this information in correctly. So we're going to scroll down just a little bit here. So we're going to come up into this cell up here, and then we're going to type schema. And keep in mind, we are grabbing the schema variable that contains the employees schema, so that employees CSV file is what we're going to be editing. Let's go ahead and type the column that we want to change. You can see that it provides some solutions here for different variables that it knows are contained. So we can go ahead and use the date of birth here. And then we need to set this equal to the Polars data type that we want. So we're going to type pl.date, and let's go ahead and print this out. In the output, we get our updated schema with the correct date data type. From here, we can reread the data in using this new schema. Let's go ahead and do that now. So we're going to, once again, copy and paste. This time we're going to go all the way to the very top and grab this here. Let's scroll back down. Put it in there, and then we're going to actually just pass in the new schema. So there is a schema parameter that we'll be using, and then we are going to use the schema variable that we defined above. Let's go ahead and also print this out so that we can see our data. And in the output, we get our data frame once more, this time with the correct data type for date of birth. Now, I mentioned that a best practice would be to infer your schema initially and then save it for subsequent data loads. Unfortunately, Polars does not currently have a way to do this easily. One way to accomplish this task would be to copy and paste a displayed version of a schema. In other words, if we scroll back up here, we could copy and paste this into one of our code cells, and then we just need to edit it a little bit. And what we would need to do is add a PL dot in front of schema, and then also a PL dot in front of each one of these data types that we have here. Now, this might make sense for a small data set, but I recently worked on a project with over 450 columns. With a data set that big, this option doesn't make a lot of sense. To bridge this gap, I proposed a simple solution to the Polars development team. I've created a function that will allow you to read and write schemas to a JSON file. In this way, you can quickly save and reuse schemas in your data pipelines. Let's walk through them now. So I'm going to come back down into this next cell down here, and I'm actually going to copy and paste the functions from my notes. And so these are basically the two functions that will read and write the schema. You don't need to know everything that goes on here, mostly just that it will save your schema and you can reopen it and reuse it for later use. So let's go ahead and come down to this next cell, and we'll actually use this. So let's go ahead And I'm actually going to copy and paste once again from my notes just so that we can quickly do this. And I'll explain what's going on. So we've got a scan CSV that we're doing on our employees data set. And we're going to be parsing the dates initially. And then you can see that I've set the schema length inference to, can't quite tell what number that is, but it's going to basically cover all of the rows that we need in our data set. You can see that I'm grabbing the schema here and putting it into the collect schema method. And this is basically going to give us our first schema that we will eventually save. So let's go ahead and run this code. Okay, and this is the version that I have on the notebooks, so I need to make sure that I remove that. So let's go ahead and try that again. Okay, so now we get our nice schema. And now I do want to save this schema so that I can reuse it. And I'm going to use the custom functions to do that. And I'm noticing now that I did not run this cell, so I'm going to come back up here and run this. And now we can come back down and save our schema. Now, saving the schema is very simple with this function. All we need is a file path and the schema we want to save. Let's go ahead and first define our file path. And we're going to keep it very simple and just say employees.json. Just below that, we're going to use the write schema function. We're going to pass our schema. And then we're going to set the file path equal to FP. Let's go ahead and run that. And now you can see our new schema here is saved in a JSON file. I'm going to format this just so we can see it a little bit easier. So if you compare this to the schemas within Polars, you can see that it is basically the exact same. The only difference here is we can now read and open this schema using our new functionality. So let's go ahead and do that. I'm going to save this here, close it, and then I'm going to come into the next cell here. And now we can load our saved schema into a Polars schema object. Going to say read schema, and then we just need to pass in the file path. So we're just going to reuse that file path variable we used earlier. And let's go ahead actually and create this as its own variable. So we're going to say schema. Just overwrite that variable, and then let's display the schema. Okay, so now we have a Polars schema object, and we can actually use this when reading in the employee's CSV file. Let's go ahead and do that one more time. We're going to type data, set it equal to pl.read CSV. I'm going to grab our employee's CSV file here. And then we just need to pass the schema parameter and set it equal to our new schema variable. Let's go ahead and print the data out and run the code. Okay, and as expected, we have our data in our data frame. Now, I'm not sure if my proposed feature will make it into the Polars library, but if you liked this solution and want to see a version of it implemented in Polars, I invite you to add your feedback in the comments section below. And with that, we'll catch up with you in the next video.